Hey everyone, and welcome. In this video, we're going to build a complete machine learning project from start to finish. We'll be tackling credit risk modeling. So, I'm Vedant from AI Batch 0725. Here's the problem. When bank gives out a loan, it needs to know the chances that the person is going to pay it back or they'll default. That's where we come in. Our project is to build a model that can look at applicants' data, like their age, job, and financial history, etc., and classify them as good loan 0 or a risky loan 1. We'll be doing this in a Google Colab notebook using Python, and we'll compare our four different machine learning models to see which one performs the best. Let's get started. This is the first step to import all the libraries we'll need. We are using Pandas to manage our data and a bunch of tools from scikit-learn for splitting our data and scaling it. And for the models themselves, we're using import random forest and XGBoost and LightGBM. These are the most powerful and popular models out there. We'll load our CSV data from here, and it's success. We'll try this, and it is success again. So we'll jump to step two. This is the initial data exploration part. We'll instantly run df.info and df.head. The info command is great. It tells us that we have over 41,000 entries and 59 columns, and most importantly, no missing values here. If you look at the head, we can see our columns feature like age, campaign, P days, and then all the other columns like job admin, job blue collar, etc. This means that the data has already been one hot encoded for us, turning categorical data into numbers, zeros and ones, that the model can understand. So our target variable is at very end, loan status label. Okay, so analyzing the target variable. This step is the most important part of the project, understanding our target variable. When we check the distribution of loan status label, we see a major issue. It's 87. Yeah, it's 87 percentage of the data is class 0, and only 11% of the data is class 1. This is called imbalanced data set. I think about it. If we built a lazy model that just guessed 0 every single time, it would be 88.7% accurate. But it would be completely useless because it would never find the risky loans we're looking for. This imbalance will affect everything we do from here on out, how we split the data, how we train the models, and especially how we evaluate them. So now the part is processing, splitting, and scaling. So first we do a simple separation. We create X, which holds all the 59 of our feature columns, and Y, which holds our target, the loan status label. Uh, Next, we split our data into training set and testing set. The model will learn from 80% of the training data and will hold back the 20% testing data to see how well it performs on the unseen new data. Now look at this parameter, stratify y parameter. This is crucial. By stratifying, we're telling scikit-learn to make sure that both the training and testing data have the same 11.3% imbalance as our original data. This is essential for reliable test. Now, feature scaling. So, our final processing step is feature scaling. The columns age, campaign, P days, previous numbers, all on different scale. A model can get confused by this, thinking P days is more important than age just because the number are bigger. To fix this, we use StandardScaler. This transforms the features into to have a mean of 0 and standard deviation of 1. This crucial rule here is that we fit the scalar only on the training data, but we transform both the training data and the test data. This prevents any data leakage from our test set. Now, the model training part. Okay, our data is prepared. Now, for the fun part, training, we're going to train all our four models. First, we calculate a value called scale POS weight. which we calculate scale POS weight. This is directly because of our imbalanced data. We're telling the models, hey, default class one is 7.75 times like more rare than repaid class 0. Uh, when you get one right or wrong, this forces the model to care about the minority class. We initialize our four models. First is the logistic regression, a simple, fast baseline model. Then the random forest model, a powerful model that helps build hundreds of decision trees. Then XGBoost, then LightGBM. Both of these are gradient boosting models, which are famous for winning data science competitions. They're smart, they're fast, and incredibly accurate. We use a class weight, which is used as a balance parameter for the first two of our scale, POS weight for boosting models. Then we just loop through and train them on our scaled training set. Then is the evolution part of all the models. The models are trained, but which one is the best, you may ask? This is the moment of truth. Now we use the models just to make predictions on our test data, the data it's never seen before. So let's look at the results. And the overall accuracy is 87.5 percentage, which is here 88.87 percentage. That sound goes right, but remember our imbalance, we can't trust accuracy. So the real story, precision. Uh, this asks when the model predicted a default, how often it was right. Here it was only 91%, 51% of the time. Recall asks of all actual defaults in our test set, how many did our model find? And F1 score here, this is the balanced average of precision and recall in a harmonic motion. Uh, and here it is 0.94. So let's compare. Random forest was uh, wait, where is yeah, here it is. The random forest. The F1 score is quite decent, 0.94 and 0.33. Light GBM is also quite good, but by comparing F1 scores of the class we care about, class 1, we can clearly see that the boosting models XGBoost and LightGBM are winners. They are far better at task than simple logistic regression. So let's recap. We took a real world credit risk dataset, handled the crucial parts of the problem, imbalanced data, processed our features, and then trained and compared four different machine learning models. The key takeaway is that accuracy is misleading. By focusing on the right metrics like precision, recall, and F1 score, we were able to prove that the model like LightGBM or XGBoost is the best choice for the job. This entire project, I hope this was helpful. Thanks for watching.